covering climate, weather, and the industrial enterprise from Penn State Meteorology. Here is Up in the Air.
Welcome to this week's episode of Up in the Air. I'm Kasey Rigner.
And I'm Ryan Gold. We have a great episode for you tonight. We've got stories about how Hawaii is breaking a new low record, as well as how drought is affecting the rainforest.
We have a package from our very own meteorology student, Kyle Monroe. All that and more, but first, here's Update in the Air.
Golfers, caddies, and spectators yelled "4" on Sunday when it began to hail during the course of the AT&T Pebble Beach Pro-Am. The frozen pea-sized pellets covered all the greens and play had to be suspended. The final round earlier had to be delayed for an hour because of rain, and because of the hail, the tournament had to be finished on Monday. This is not the first time that the Pebble Beach Pro-Am had to be delayed. There was one round in 1962 because of snow, and in 2009, the final round was delayed until Monday because of rain, and then canceled because the system became stationary.
The Amazon rainforest isn't necessarily a place that many would associate with a drought, yet prolonged dry spells are projected to be more prevalent and severe because of climate change. The question at hand is how these droughts are going to affect the rainforest, as it has a large influence on global climate and future warming. A study led by Marielle Smith, a research associate in Michigan State's University Forestry Department, and Scott Stark, who's an assistant professor of forestry, examines the Amazon's response to droughts in order to better predict how forest growth and physiology will affect tree diversity and ultimately the planet's climate. Due to its combination of wet forest structure and a strong dry season, the Tapajos National Forest in Brazil may be a good indicator for climate change responses, which is what led researchers to the location. The expectation was that when the amount of leaves in the tall trees increases during the dry season, it gets shadier underneath, and smaller trees lose some of their leaves as a result. Instead, it was the small trees that were in open areas where shading was low and sunlight was high that lost the leaves. Trees that were shaded surprisingly added leaf area at the same time as the tall trees. The trends were the same in response to drought. The research is helping build a picture of how canopy, microenvironments, tree heights, seasonality, and drought come together to determine which trees will win and lose under drier climates.
Winds blowing across snow dunes on Antarctica's Ross Ice Shelf caused the massive ice slab surface to vibrate, producing a near constant set of seismic tones scientists could use potentially to monitor changes in the ice shelf from afar. According to new research, the Ross Ice Shelf is Antarctica's largest ice shelf, a Texas-sized plate of glacial ice fed from the icy continent's interior that floats atop the Southern Ocean. The ice shelf buttresses adjacent ice sheets on Antarctica's mainland, impeding ice flow from land into water, like a cork in a bottle. Ice can flow faster from land to sea when ice shelves collapse, which can raise sea levels. Ice shelves all over Antarctica have been thinning and in some cases breaking up or retreating due to rising ocean and air temperatures. To better understand the physical properties of the Ross Ice Shelf, researchers buried 34 extremely sensitive seismic sensors under its snowy surface. The sensors allowed the researchers to monitor the ice shelf's vibrations and study its structure and movements for over 2 years. From 2014 to 2017, the several meter deep snow layer atop the ice shelves acts as a fur coat for the underlying ice. When the researchers started analyzing seismic data on the Ross Ice Shelf, they noticed something odd. Its fur coat was almost constantly vibrating. It turns out that the winds across the massive snow dunes caused the ice sheet snow to rumble, like the pounding of a colossal drum. The ice vibrated at different frequencies when the strong storms arranged the snow dunes or when the air temperature at the surface deviated, which changed how fast seismic waves traveled through the snow. Changes to the ice shelf's seismic hum could indicate whether melt ponds or cracks in the ice are forming that might indicate whether the ice shelf is susceptible to breaking up.
New research undertaken at Northumbria University, Newcastle shows that the sun's magnetic waves behave differently than currently believed. After examining data gathered over a 10-year period, the team from Northumbria's Department of Mathematics, Physics, and Electrical Engineering found that magnetic waves in the sun's corona react to sound waves escaping from the inside of the sun. These magnetic waves play an important role in transporting energy around the sun and the solar system. The The waves were previously thought to originate at the sun's surface, where boiling hydrogen reaches temperatures of 6,000 degrees and churns the sun's magnetic field. However, the researchers have found evidence that the magnetic waves also react higher in the atmosphere by sound waves escaping out from the inside of the sun. This newly discovered marker is found throughout the corona and was consistently present over the 10-year time span examined. This suggests that it is a fundamental constant of the sun, potentially being a fundamental constant of other stars as well.
We all expect Hawaii to be the warm tropical vacation spot, but a recent storm has lowered the temperatures to well below freezing, a potential record-breaking low. Just after midnight on Monday the 11th, a few sensors on top of the volcano Mauna Kea dipped below 12 degrees Fahrenheit. These temperatures still need to be confirmed, but if they are accurate, this would beat the current record of 12 degrees set atop the volcano in May of 1979. Not only was the temperature well below freezing, but something else added to the tropical island to make it feel closer to the north: snow. Given how cold this storm was, there was reports on top of Kahalealea, a broad shield volcano on the island of Maui. This, however, isn't unusual given its elevation. Regardless, it was certainly a bizarre sight, not only for the locals, but for tourists attempting to get away from the cold here in the continental states.
Climate change is causing significant changes to phytoplankton or algae in the world's oceans, and a new MIT study finds that over the coming decades, these changes will affect the ocean's color, intensifying its blue regions and its green ones. Satellites should detect these changes in color, providing early warning of wide-scale changes to marine ecosystems. The researchers say they have developed a model that shows how the mix of species in various locations will change as temperatures rise around the world. They ran the model through the end of the 21st century and found that by the year 2100, more than 50% of the world's ocean's colors will shift due to climate change. The study suggests that the blue regions, such as the subtropics, will become even more blue, reflecting even less algae in those waters compared to today. Some regions that are greener today, such as near the poles, may turn even deeper green as warmer temperatures brew up larger blooms of diverse phytoplankton. According to their model, climate change is already changing the makeup of phytoplankton and by extension the color of the oceans. By the end of the century, our blue planet may look visibly altered. Welcome back to the show. We now have a feature from Kyle Monroe about how CATA uses natural gases.
The ocean plays a huge role in eliminating greenhouse gases from the atmosphere. The ocean and the living things in it, such as plankton and algae, absorb greenhouse gases. However, there are more greenhouse gases being emitted into the atmosphere than what the ocean can absorb. In order for an equilibrium to be reached, there must be a reduction in the rate of greenhouse gases being emitted into the atmosphere. We can thank the public transportation industry for taking an initiative in reducing the amount of greenhouse gases being emitted into the atmosphere. Some public transportation companies are switching to compressed natural gas powered, also known as CNG vehicles, just like here in State College, or even electric vehicles instead of the traditional diesel powered buses. But how much less emissions do CNG buses such as the ones used by CATA produce compared to the diesel powered buses such as the ones used by SEPTA in Philadelphia? It turns out that CNG buses are in fact cleaner and produce less emissions, but they have a higher rate of fuel consumption. When actual bus runs are compared, it was found that CNG-powered buses produce about 8% less emissions than diesel-powered buses, which is good, but not enough. A new study has found that oceans are absorbing about 10% less emissions since 2000. This is because the waters are becoming warmer and more acidic. Greenhouse gases such as carbon dioxide absorb into ocean much easier when the water is cold and dense. As the ocean gets warmer and warmer, it will be less and less able to take in these greenhouse gases. This just emphasizes the importance of globally reducing the amount of greenhouse gases, especially the ones produced by burning fossil fuels.
So, in an unrealistic scenario where the only greenhouse gases being put into the atmosphere were being produced by public transportation, every single bus was now a CNG-powered bus, and the only method of eliminating greenhouse gases was the ocean, then there would be an 8% reduction in the amount of greenhouse gases going into the atmosphere. But as the study found, the ocean is absorbing 10% less of those emissions. So the rate that the ocean is absorbing is going down faster than the rate and amount of greenhouse gases being produced.
If we want to reach an equilibrium state where the amount of greenhouse gases being put into the atmosphere is the same or even less than what the ocean is able to take in, there needs to be a global reduction in the rate of greenhouse gases going into the atmosphere, more than just what the public transportation industry is doing. For Up in the Air, I'm Kyle Monroe.
Welcome back to the show. Ryan, we had a coating of snow overnight Sunday into Monday. We actually had a busy beginning of the work week, as then we had the snow Monday night into Tuesday, changing over to that wintry mix, leaving the roadways icy, changed back over to snow overnight Tuesday and into Wednesday morning.
Yeah, we finally made it through the weekend, though. Although just the week. Sorry, we haven't made it through the weekend yet. But that's when we get thawing. Hopefully, we're not going to have to get through any snow or precipitation to get to the BJC. But we'll figure that out from Joe at the Climate Wall. Joe, what do you know?
All right, thanks, Kasey and Ryan. We'll take a look at what's coming up this weekend in my weekend forecast coming up. But first, let's take a look at the climate data for February 14th. We have an average high of 37 degrees and an average low of 22. And our highest high was a 66-degree reading, and it came back in 1954. And our lowest was -7 degrees back in 1943. Now, if we take a look at temperature across the country as a whole for February 19th to February 25th, we see we have some pretty high chances of having below normal temperatures out in the northwest, mainly reaching the northern Rockies. But we can take a look and see how it reaches down into northern Arizona and reaches into some of the Californian border. But our above normal chances come down in Florida as expected and reach up into the south, hitting some parts of Georgia and Alabama. And then as we take a look at our region up in New England, it's a slight chance to have below normal temperatures, and in State College, it's as you'd expect in the general region of New England. And then as we take a look at precipitation as well, we have some below normal chances coming out in the California region, where San Francisco is seeing that higher concentration of below normal chances. And then as we zoom out and see some above normal chances, we have it occurring over towards the Mississippi region, hitting down in the Iowa border and parts of southern Dakota. And then we have a larger chance coming out in the southeast, hitting, again, Alabama, Georgia, and Mississippi. And then as we take a look back into our New England region, as you'd expect, a slight chance to have above normal temperatures in State College, experiencing that as well. And then we take a look at our droughts. Just like we saw last week and in last episode, a lot of the droughts concentrated in that Four Corners area, and it's even shifting over towards Colorado and parts of New Mexico. And then we see some again occurring up in the central part of Oregon, not what we saw last week. And then again, a little bit of a concentration of drought happening down in the southern tip of Florida, and then again in our region, not seeing much drought. But we take a look at snow, and just like we saw last week, Canada has a lot of it, but if you ask me, they can keep it. And then if we head over towards the Sierra Nevadas, again, we have a lot of snow, and even in the northern parts of the Rockies. And as we shift along the northern border of the country, we see it reaching into the Great Lakes area. And then in State College, we're seeing a little bit after what we've seen this week. And then, as I mentioned before, let's head into our weekend forecast. We have snow showers coming in on Saturday with a high of 32 degrees, right in time for thawing to pick up. And then on Sunday, we have some AM snow showers, and it'll clear up a little bit, but it's going to come back in the afternoon, and we have a high of 31 then as well. So back to you guys at the desk.
Wow, that does not look great for thawing. If you have to stay outside to wait to get in, you're going to want to bundle up. You might want to have an umbrella as well.
That's a smart idea. Thank you so much for joining us this week. Make sure you catch us next weekend up in the air.